On to the spiral. So just a little bit more to go. All right, they want to find the area of the parallelogram. Well, I can see the base here is 12, and if it's not real clear, I'll just write it under here. Base is 12. And area for parallelograms, you get your math chart, rectangle or parallelogram, area equals little b times height. Little b means an edge. Area equals little b times height. Well, there's 5 inches. That's not really the height. The height is this up and down line. Well, they gave me a hint here. There's a reason they gave me that 30 degrees. This makes this, if that's a right angle, that's a right angle, and that's 60 degrees. This is a special right triangle. Let me see if there's a shortcut here. Here is the same triangle. This is like my height. If this is 5, how does this side compare to the hypotenuse? You can see that the hypotenuse is double the little side. Or you could say the little side is half of the hypotenuse. So I'm going to say the little side here is half of 5. 5 divided by 2, which is 2.5. So I can just find the area by going 12 is the base times 2.5. Use your calculator, clear 12 times 2.5, and you get 30. And inches squared. Remember, area is square area. All right. Now we have RG has endpoints -3, 6 and -9, 2. So let's go ahead. They gave us some graph paper. Let's use it. -3, 1, 2, 3, positive 6, 1, 2, 3, 4, 5, 6. All right. So that's R. And -9, 2. 1, 2, 3, 4. Wait. 1, 2, 3. 4, 5, 6, 7, 8, 9. That makes sense because most of these kind of go to 10. And then I got to go up 2. So there's my real point, G. All right? If I'm trying to connect these two, they want to know what is the length of this line. I'm actually going to go ahead and notice I could use the formula, right? But right triangles are actually your friend. They really, really are. So this side here, see, there's my little right triangle box, is 4 long. This side here is 1, 2, 3, 4, 5, 6 long. Okay? So I can just use Pythagorean theorem to find out this side. 6 squared plus 4 squared equals, and I'll just say d squared. 36 plus 16 equals d squared. 1636, I'm getting 52 equals d squared. So d is the square root of 52. Now, what's the midpoint for this? Well, you can use the midpoint formula. On this one, it actually does go through a pretty clear point. You can see it goes through 6, 4. I'm sorry, -6, comma, positive 4. All right? Then they want the, but if, let's say you're like, oh, okay, I didn't want to eyeball it, I want to be exactly right. Use the midpoint formula equals x1 plus x2 all over 2, and do the same thing for the y. And guess what you're going to get? -3 plus -9 is -12. Divided by 2, you get -6. 6 plus 2 is 8. Divided by 2, you get 4. So you'll get the same thing. What is the equation of the perpendicular bisector? So the important thing to know is what is the slope? Well, it goes up 4 over 6. So the slope is 4 over 6, or 2/3. If it's a perpendicular bisector, the perpendicular slope, you flip and change sign. So it's -3/2. They didn't give us a lot of room, did they? So I know the point that the bisector has to go through. Bisector is cut in half. Okay, very bloody business. And we use the point slope formula. Y minus y1 equals m times x minus x1. Y minus 4, remember it's got to go through the midpoint, equals -3/2 x minus -6. Then we go y minus 4 equals -3/2 x, and when this is going to be plus, 6 divided by 2 is 3 times 3 is 9, and it's going to be -9 plus 4 plus 4, negative 3 halves x, don't drop the x, minus 5. That is the equation of your line. Oh, all that work in that tiny little space. You see it? Okay, then the question was if RG is reflected over the y-axis, okay, what is the slope of the segment? So the easiest way to do it is to measure the distance to the points. You're going to take this point and move it and reflect it over here. You could fold it over and trace it, but you're not always going to be in a good position to do that. So the other way you can say is this one has to be the same distance from this line on both sides if it's reflected. So this is 3 away. 1, 2, 3. Here's this point. This one is 9 away, and it's on this line, so I'm going to go ahead and move it right there. Okay? If I connect the dots and I make my right triangle, what is the slope of this line? First of all, I can see the slope is negative. They could have given me a little more room for that problem. Slope's negative. I went down 4, that's why it's negative, and over 6. So my slope is negative 2/3. If you have any questions, please feel free to bug me. I hope you spent time studying for your test, and I will see you